On today's episode, copper, the critical material for transportation electrification. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. We've all seen the news stories about the critical engineering inputs to electrification of the global economy. Lithium, cobalt, nickel, and rare earth elements have been studied extensively, as well as the supply bottlenecks and predicted production shortages that have driven battery prices higher in electric vehicles. Rarely discussed, however, is a critical input not only for electric vehicle batteries, but for the entire electricity infrastructure: copper. According to a new report by S&P Global, supply shortages of the world's most important metallic conductor may seriously hamper the popular net zero emissions target date of 2050. Copper is essential in the windings of electric vehicle motors, as well as in transformers and the cabling necessary to build out a nationwide electric vehicle charging infrastructure. According to the study, electric vehicles require 2.5 times as much copper as an internal combustion engine vehicle. The report also states that copper demand will double to 50 million metric tons annually by 2035. That's more than all the copper consumed in the world between 1900 and 2021. According to the International Energy Agency, copper and nickel prices have increased between 25 and 40% since 2021, an increase which has been in the background of much larger increases in critical battery cathode materials. Unlike storage batteries, however, there is no practical alternative technology to replace copper as an electrical conductor in mobility applications. The availability of copper ores, however, is not the supply bottleneck. According to the U.S. Geological Survey, global reserves are estimated at 870 million tons, and current annual copper demand is about 28 million tons. Current total available copper resources are estimated to exceed 5,000 million tons. And while copper ores are well distributed around the world, Chile leads the globe with 27% of the global market share by tonnage. Peru follows with 10%, followed by China and the Democratic Republic of the Congo at 8% each. The United States ranks 5th with 6% of world supply, 1,200,000 tons annually. No other nation has more than 4% of global supply. With over 1/3 of global supply controlled by 2 South American nations, maintaining stable pricing in a world where global supply chains are now uncertain suggests that U.S. domestic production will be a priority. To address this, last year the Biden administration announced $2.8 billion in grants to primary producers of electric vehicle minerals, including copper. From an engineering perspective, there's another critical factor to consider in copper production: dependence on large amounts of cheap and clean electricity. Copper is electrolytically refined from intermediates of over 99% purity, a purity achieved with smelting and chemical processing. This means that the refining process uses high-value and highly concentrated inputs from the smelting or leaching processes, meaning that electro-refining can take place in jurisdictions where electric power is cheap and plentiful, not necessarily in the same location where the ore is mined and processed. As green electricity technologies drop in cost, the possibility of moving the entire production process closer to the ore body is possible, but it's not essential. For the other commodity metals needed for EVs such as nickel, the basic reduction process needed to produce the metal is performed in electric furnaces with power needs on the order of dozens of megavolt amperes, meaning a low-cost source of considerable electricity is required for refining. So will the Biden administration attack the problem from the perspective of the mining of ores, smelting, or refining? It can take a decade for new sources to come on stream, but unlike battery chemistry, there is no alternative for copper now or in the foreseeable future. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.